let us consider the design of 4x1 MUX. So in 4x1 MUX we do have 4 input data lines. Let us denote the 4 input data lines as D0, D1, D2 and D3, and we do have only one output line, that is referred as F. Whatever be the number of inputs, always the output of multiplexer will be single. It is going to have only one output line. And what is the functionality of multiplexer? It has to select one of the input. So it has to select either D0 to appear at the output, or D1 should be allowed to go out, or D2 should be allowed to go out. So which of the input is selected to appear at the output? So that is dependent on the number of select lines. So if 4 inputs are there, we know that we are going to have 2 select lines. Let us denote them as S0 and S1. So what is the relationship between the number of select lines and the number of inputs? If n number of select lines are there, we do have 2 raised to n number of inputs. So now n is equal to 2, and therefore number of input lines are 4. So that's why this is referred as 4x1 MUX. So since it is going to select one of the input, this MUX is also referred as data selector. Data selector. So it is going to select either D0 at the output, either D0 will come at the output, or either D1 will come at the output, or it will select D2 to go to out, or last D3 can come outside. So when D0 will come, so for that let us build a truth table. The output F is dependent on the select inputs S0 and S1. So since 2 inputs are there, we are going to have 4 number of combinations. What are the combinations? What are the 4 combinations? How we build it? This LSB select line is alternatively made 01, 01, and MSB is S1, most significant digit, it is twice 0, twice 1. So we have constructed 4 different combinations of the inputs. Now 0, 0, what is its decimal equivalent? It is 0. So that is D0 input will come at the output. F will be equal to D0 if S0 and S1 are set to 0. Similarly, when S0 and S1 are S1, S0 are 0, 1. 0, 1 means the decimal equivalent is 1. That is D1th input. This input will come at the output. D1 will be at the output. Will be at the output if S1 is 0 and S0 is 1. 1, 0 means decimal equivalent of 1, 0 is 2. Then D2 input will come at the F. 1, 1 means it is 1, 1 means 3. So D3 input will come at the output. So when we are going to have D0, we are going to have D0 when S0 and S1 are 0, 0. S0 and S1 both are 0, 0 means both are bars. When we will be having D1, S1 is bar, S1 is 0 means S1 bar, S0 is 1, S0. So S1 bar, S0. For S1 bar, S0, D1 will be appearing at the output. When D2 will come? D2 will be coming when S1 is 1. S1, S0 is bar, 0. So for the S1, S0 bar, we are going to have D2 at the output. When D3 will be appearing? When both S1 and S0 are 1, 1. No bars. So it is S1 and S0. Okay. So this is our logic expression. Logic expression for 4x1 MUX. And this is our truth table. Now let us see the realization of 4x1 MUX. So we shall see realization of 4x1 MUX using logic gates. That is, we are going to see logic diagram of 4x1 MUX. So the diagram appears like this. For that we'll have to refer this equation. So the equation contains of first term is a product of these three variables. So second term is also product. So in final we are going to have 4 terms. Each of the term is a product. So product means it's multiplication. So to implement first term we are going to use one AND gate. Similarly second product term requires one more AND gate. In total 4 products are there in the equation. So we need 4 AND gates. And finally we are going to combine them. So to combine we are going to use an OR gate. So this is first AND gate. The first AND gate is going to give S1 bar, S0 bar, D0 as the output. Similarly, the second AND gate, with that we are going to get S1 bar, S0, D1. This is the second term got at the output of the second AND gate. The third AND gate is going to produce S1, S0 bar, D2. Similarly, fourth AND gate is going to produce S1, S0, D3. So here D0 is connected. Next here we are going to connect D1. Next third AND gate's input to third AND gate input, D2 is connected. To the last one, D3 is connected. Now let us have 4 lines created here. So it is the line for S1. This is S1 line. This is S0 line. So from S1 line we are going to get S1 bar by connecting a NOT gate. Similarly, here we are going to connect one more NOT gate to derive S0 bar. So both S1 bar and S0 bar are needed to be connected to this line. So both bar lines, S1 bar and S0 bar,